Hello children. This video especially I have made to show that why the properties of same group elements are similar. What is the reason? What is the cause? Okay, all the elements of this group means first group will show similar property. Similarly, all the elements of this group will show similar property and so on. All the members of this group will show the similar property. What is the reason behind this? Reason behind this is that their valency is same. Okay, valence electron in last cell is same. That's why they are showing the same type of property, whether they are ready to lose number of same number of electrons, or they are ready to share same number of electrons, or they are ready to gain same number of electrons. I hope you understood. I am talking about valence electrons. Fine children. For example, this is our first group. Here the members of this group is hydrogen, lithium, sodium, potassium and so on, and you can see their atomic numbers are different, like 1, 3, 11, 19 and so on. So we will see how valence electrons are same, and that is the main cause. Because of that, these elements are showing similar group, these are similar groups, these are showing similar group, these are showing similar groups and so on. Okay, so I am going to explain about that, and heading of my topic will be elements of same group have same number of valence electron. So I have chosen first group to explain you. I have taken hydrogen, then lithium, then sodium, whose atomic number is 11, and then potassium. Okay children. Okay, I have written atomic number on base of left side, and we know that formula, that maximum number of electrons in one cell is what? How many electrons can revolve in one cell? That is equals to 2n square. Means n is what? That is number of cell. So in first orbit, this is the first orbit for any element. First of all, first orbit will fill, then the second cell, then third cell, then fourth cell, in that way. So hydrogen having only one atom, it means number of atom is equals to atomic number is equals to number of electrons, right? So if number of electron is 1, because atomic number is 1, so hydrogen is having 1 electrons, but what we have to know that how many maximum electrons can revolve in 1 electrons. For that I was writing here that in first orbit this is 2 into 1 square, that is 2. It means in first orbit of any atom only 2 electrons, maximum 2 electrons can survive, but hydrogen is having only 1 electron, so there is 1 electron in its outermost orbit. Okay, what about lithium? So here is lithium is having 2 atomic number, so number of electron is also 2, so both will be in first cell. Okay, so you can see for lithium also how many cells are there. This is not 2, this is 3. So 2 in first orbit and 1 will be in third orbit. Why the third electron in second orbit? The reason is that, as I told you, in first orbit only 2 electrons can survive. And what about second orbit? Again we will use the formula 2 into n square. So 2 into, for second orbit, 2 square. Instead of n we have written 2 because number of cell is 2. This is k, this is l. So 2 into 2 into 2, that is 8 electrons. Maximum 8 electrons can revolve in second orbit, that is in L cell. Okay, and lithium is having 3 atomic number, so 2 is in first orbit and third one is in outer orbit. Can you see in outer orbit of hydrogen there is 1 electron, that is valence electron. Here again in lithium there is 1 electron, that is its valency. Okay, similarly in sodium we will see first, here is sodium, so this will be maybe first orbit, so 2 electron in first orbit, 2 and then 8, 2 and 8, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8. We have shown that in second orbit there will be 8 electrons. Still 2 and 8 means 10 electron, and how many electrons are in one atom of sodium? That is 11 electrons. So 1 will be here in third cell, so 1 electron. Again you will see in outermost orbit valence electron is 1, and we have to see what is the limit for third cell. Again we will write 2 into 3 square, that is 2 into 3, 3 is 9. It means 18 electrons can revolve in this orbit. Okay, that is the highest limit. Now for potassium is 19. So in that way you can arrange this one also. So let's see the table. With the help of this one I have made the table to explain you. See children, what I did, I made written the heading, and then elements of first group are hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So I have made the table, serial number, elements name, their atomic number, electronic configuration, K, L, M, N, as I was showing you with the help of diagram. Just for explanation of this table I was doing this diagrammatic work. Okay children, now why I have written 1 here, that you understood, because I have shown you here in diagram that in first orbit of hydrogen, first cell, there is 1 electron, because hydrogen, one atom is having only 1 electron, so it is 1. Okay, number of cells, how many cells are there? 1 cell. You have seen here only 1 cell and 1 electron. And in lithium, 2 cell. In outermost orbit, how many electrons? 1 electron. So you just see here in lithium I have written 2. In first cell 2 electrons, in second cell 1 electron. I have shown you diagram also. This is K cell, this is L cell. Okay, so 2 and 1. So how many cells are there? 2 cells. Understood? In one atom of lithium there are 2 cells, and number of valence electrons means how many electrons are present in outermost orbit, that is 1. Similarly in sodium I have shown you there are 3 cells in, because 11 electrons are there, so 2 electron in first orbit, that is K cell, then second orbit, that is L cell, and 1 is left, that is in third cell, that is M cell. Okay, so how many cells are there? 3 cells. Okay, see the size of atoms are increasing, but in outermost orbit the number of electron is 1. So I have written number of valence electron is 1. Similarly in potassium 2, 8, 8, 1. I will explain you why not 18. As I just told you about the formula 2n square, I will explain you about that detail. Okay, so wait for that. When I will explain about valency and electronic configuration, I will explain you why it is not 2, 8, 18, why it is 2, 8, 8, 1. Okay, for that you need proper explanation, and I will explain make a proper video based on this thing only. Okay, so how many cells in potassium? 1, 2, 3, 4, but in last 19 was there, so 2, 8, 10, 10 and 8, 18, 18 and 1 is 19. So again you see there are 4 cells, but in outermost orbit again 1 electron is there. Okay, and children try to understand, because 1 electrons are there, so these all are ready for what? These all are ready to give their 1 electron to other element who is having maybe 7 electron, to complete their octet and make a compound, stable compound. You got it? You must have learned about the rule octave. You haven't learned, then you must watch my video where I have explained about octave, and I will give the name of that video, octave. Try to understand. Okay, so these all elements will try to donate their 1 electron to the other element, so that their octave will be completed. And here hydrogen, in exceptional case, hydrogen is ready to donate 1 electron, or it may accept 1 electron to complete its duplet. We will come back again in this topic when we will learn about hydrogen. One special topic I will make about hydrogen. There I will give you all the details. So all the elements of first group have 1 electron in their valence shell and have different number of cells. Same thing I have shown you there. Okay, structure of hydrogen, lithium, sodium and potassium, showing their contribution of electrons. Fine children. So this is the reason, this is the only reason, whatever we have learned here, you have to understand why the one group element are showing same property, because they all are having same number of valence electron. Like in this cell, number of valence electron is 1, so that property, that quality is with every element of this row. Here in this group, all the elements are having 2 electrons in their outermost orbit, so they all will behave similar, and they will show similar property. That's why Mendeleev, as well as Mendeleev in Mendeleev periodic table, Mendeleev has arranged those elements in one group whose properties are similar. Although he has arranged the elements on the basis of atomic mass, while now modern scientists have arranged all these elements on the basis of their atomic numbers, but common thing is that they kept all the elements whose properties are similar in this same group. And reason is that, as you have seen, that valency is same, valence electron in outermost orbit is same. Like in this group, all the electrons are having, if you are going to check with the electronic configuration, I will teach you how you will write learn the method to writing electronic configuration to know that how many electrons are in outermost most orbit. Here you will see that all elements of this group is having 3 electrons in their outermost orbit. That's why we are saying that what elements of same group have same number of valence electron.